If you're anything like me, you've probably seen all of these headlines that have been popping up around northern lights and how they're becoming more and more intense and visible further and further south. And there's a good reason for that, and it has to do with space weather. And while this might be great for everyone who wants to look at some pretty lights in the sky, if you're like me and you work in tech support with RTK equipment, it comes with a lot of headaches the next day. And in this video, we're going to break down what is causing those northern lights and why it has such an effect on GPS equipment. So let's get into the video and talk about what is causing these northern lights. If you're a surveyor, you've probably been experiencing some of the side effects of these solar storms, and you've seen your position become unstable, maybe even your RTK equipment become unusable, especially if you've been using it on a day-to-day basis this summer. So before we understand why GPS signals are affected by solar activity and why you might see that degradation of performance and positioning in the field, we need to understand what the sun is doing to the Earth. So normally what happens is the sun is a giant nuclear reactor, but it's relatively calm. It sends out light to us, we can grow plants, we live on Earth, we don't really notice anything, but every once in a while, the sun becomes a bit unstable and ejects what is called a coronal mass ejection. This is basically a wave of plasma that gets thrown off the sun that contains a bunch of protons, it contains electrons, more or less a bunch of electrically charged particles. And as it flies towards the Earth, what is happening is it's going to hit the Earth. And normally we have this nice magnetic kind of bubble around the Earth. It's nice and stable. It's what is powering the magnetic poles, all of that kind of thing. We don't notice anything. But when this wave hits the Earth, this magnetic field basically gets deflected. It no longer is nice and around the Earth. It becomes unstable, and it has a whole bunch of effects on things beyond just the northern lights. Because these particles are hitting the atmosphere, we're getting all these lovely colors from all the fun chemical reactions that are happening and these ionizing particles hitting this magnetic sphere. Beyond these nice pretty colors though, we get a whole lot of nasty effects for GPS. So let's take a look at what is happening to our GPS signals. So in order to understand what is happening to these GNSS signals and these solar events, we need to understand how they interact with our atmosphere. So it's just like this glass of water. As our satellite signals, which I'm going to represent with a straw, enter the atmosphere, they're going to get refracted. So much like how the light beams are refracted from the changing density from the water to the air to the bays, we're doing the same thing with GNSS signals. As they pass through different parts of our atmosphere, they're being changed. So what modern receivers do is they model the ionosphere to understand this refraction coefficient and how they interact in different parts of the world. When we have a solar event, these models are completely irrelevant. They're no longer valid, which means our positioning becomes very unstable as we're not properly able to account for this refraction coefficient. So what does this look like in the field? Right, so we understand what is happening to our GNSS signals. So what does it actually look like to you in the field? And we were fortunate enough, we had one of our best customers here in town who recorded some data during one of these solar events just by happenstance while he was doing another test for us. And what we see is we've got this nice stable periods at the beginning and end of our graph here where the solar activity was exactly as we expected. The ionosphere is able to be modeled very easily. There's no disturbances, but right here in the middle, which we've highlighted with yellow, we see this kind of almost random placement of points, and we see no stability. There's no real pattern that we can observe. There's no consistency. They're all over the place. And we saw points varying as much as 5 centimeters, which for an RTK solution is pretty enormous. And this was directly caused by these solar disturbances. So what can you do to mitigate this while you're in the field? Well, there's a couple of things. First and foremost, I would recommend checking out NOAA's space weather prediction service. I'm going to put a link to it down in the description down below. It gives you a prediction for the next 3 days of the solar activity, what the current solar activity is, and you can kind of use it to do a bit of planning to make sure that you're not going to be going into a really tough environment with high solar activity. So if you see KSP values of kind of around 1 to 5, don't worry about it too much. As soon as you start pushing 7, 8, 9, 10, you might want to either break out the total station if you got to get some work done, or maybe wait a couple of hours for the solar activity to calm down. With all that being said, right now, as you've probably guessed from all the headlines around solar activity, we're in the peak of our solar activities cycle. So these go in 11-year cycles, and kind of every 11 years, they flip from high activity to low activity. The good news is we're at the very tail end of the current cycle, so we should see a nice calm period for the next decade or so. So for those of you who are getting close to retirement, good news, you're probably never going to have to deal with this again. For those of you like me that are younger fellas, we're probably going to be dealing with this again in about 10 years. So don't forget everything you learned in today's video. And the last thing you can do is make sure that you have the most up-to-date equipment. So modern 7th generation receivers like the Hemisphere S631, the Trimble R12, the Leica GS18, all of these are starting to integrate solar mitigation technologies. So these solar flare events don't cripple you for the day like they would on older equipment like your GRX2 2s, your aforementioned GSR 2700s, any of these older equipment that aren't able to handle this solar activity. So another important reason why you need to stay up to date with the latest equipment and make sure that you're fully utilizing what is available to you so you can get the most out of your surveys in the field. With that being said, I hope to see you on the next video, and if you enjoy this kind of content, hit the subscribe button down below and give us a like so we can keep making it.